Hey everyone, my name is Abbas and I am hosting LaravelNagpur meetups for the past 4 or 5 years. This will be our 65th meetup, by the way. Thank you everyone who has joined us so far, and I can see a lot of a couple of new faces. Maybe Mohin. Mohin, can you please switch on your camera? In fact, everyone, please, if you can, if you have video cameras, please switch it on so that we can take a group photo.
Yes, sure. Just
Sudipta, Rakesh, Caleb, Archana, Mohin. Okay, let's me take a quick screenshot and then we should be done with it. Okay, so this month we have Michi Hoffmann with us. Michi is a software engineer at Sentry, and he'll be presenting a talk on how to profile your PHP code. Without any further ado, I'll hand it over to Michi. Michi, please take it on.
Thank you very much. Good evening, everyone. Thanks for having me. So yeah, today we will talk about profiling your PHP code. If you could just give me a quick thumbs up if you can see the slide. Okay, are we good?
Yes, we can see a slide.
Perfect. Okay, cool. Let's get started. Yeah, so today I will talk about profiling, a little bit how it works from the perspective of the Zend engine, so the virtual machine slash compiler PHP actually runs on, what kind of profilers there are, more importantly, how then to actually visualize your profiling data, and most importantly, why you should also start to profile your PHP code, like the benefits you get from it. I'm currently living in Vienna, in Austria. That's a small country next to Germany in the heart of Europe. And there I work out of our Sentry office, and I'm tech leading all our SDKs we build at Sentry. So besides PHP, Laravel, Symfony, we also have Go, Rust, Python, Java, every JavaScript flavor you can think of. So this is all done in our Vienna office, besides a few other things. When I'm not coding, I'm into photography, so walking around cities or taking photos at events. And in general, I also like everything around aviation. And as you might have seen, I also pretty much into fingerboarding, so like these tiny skateboards you can make tricks on. Yeah, I love profiling. Profiling when it comes to telemetry, so basically collecting data about your application. This could be logs, this could be errors, this could be any other thing. Profiling is the one I actually enjoy the most. And the reason being is that the insights you can get out of profiling data is just so detailed, and it doesn't really match any other kinds of telemetry we have out there. And it's the sole thing that really helps you to find like performance bottlenecks, mostly in terms of like processing time. But it also helps you to spot regressions. So let's say you ship a big refactoring, and then all of a sudden certain things in the application are slow. Profiling helps you to find them, and more importantly, then also let you fix them. And you might already collect your errors, right? And error monitoring is really helpful. Hey, something is broken, I need to fix it. But besides that, profiling for me over the last couple of years has been like probably the most important tool in my toolbox as an engineer. So what is profiling actually? It's not tracing. Yeah. So when we talk about tracing in the whole applications performance monitoring or APM space, we normally refer to measuring certain operations. So this could be like how long does it take to make an HTTP call to another application? how long does a database operation take, how long does it take to render a blade template. So all of these things we measure in spans. So a span has a start and an end timestamp, and then all these spans together in a certain service, they give you most of the time the request time it takes to process one request. And then if you have like maybe multiple microservices, you can also connect all of these spans together. And then you see like a nice visualization about the path through your applications. And it also tells you how long it takes. So this is all cool, but this is very high level, right? Normally you don't trace or wrap your every function into a span. So you don't really know how long certain business logic in your application takes. And for that, profiling is a much better solution than tracing. That's a pretty broad statement about profiling, but in our case, we want to go a little bit more deeper. So what we want to do in essence is we want to figure out what our application is doing, where it spends too much time on, where it maybe consumes too much memory. But today we really want to focus on the part where your application is spending the most time running your code. So we won't look into memory profiling. So now we roughly know what profiling is. And there are different types of profilers when we want to profile our PHP code. And the ones you're probably most familiar with are called deterministic profilers. So deterministic profiler is meant to reflect that all function calls, function returns, and exceptions are vendor monitored. So this means from your index PHP all the way up to your models, controllers, views, every single function that is called is being recorded. And they are very, very precise. Nothing random is happening. You get the full picture. If you want to implement such a profiler, could you? Yeah, thank you. If you want to intercept all these functions, the Zend engine under the hood exposes certain hooks we can register. So in the old days, so during PHP 7 and before, we could register a hook on the send execute extension function pointer. And then every time a function was called, we could record it. These hooks add a tremendous amount of overhead to your application. And more importantly, if other extensions also register these hooks, there's a big problem in terms of the noisy neighbor syndrome. You basically had to manually forward all of these calls to neighboring extensions. So they were not really a good fit. Since PHP 8, we now have a completely new overhauled Observer API, has much lower overhead, is completely separated from other extensions, and it really helps you to build like profilers, traces in a much more efficient way. A few profilers for these a few examples for these deterministic profilers are, for example, Xdebug. So this is something probably everyone has heard of. Xdebug allows you to set breakpoints, and then you can attach it to a debugger, for example, in VS Code or PHP Storm, and then you can just step through your entire application. But it also comes with a function level hierarchical profiler. And it can also collect memory usage and other things. And to visualize Xdebug profiles, you could use something like cache current. So this then gives you like a complete hierarchical overview of your entire application. So on the left, you see like the function call stack. And like locally, this is pretty helpful to find problems. Another one of these low-level hierarchical profilers is XHProf. And there's a plethora of like different visualization tools available. So this one is called XHGUI. You can just run it in your browser. And it can also store all the profiling in a MongoDB or PDO database. And then even locally, you can look at aggregates. So basically the combined data of multiple profiles. A bit more modern and actually a pretty nifty one is called SPX, the simple profiling extension. Again, this can collect various metrics, time, memory, which files you are including, which objects are in use, input, output. And it has a pretty cool UI. So that's how it looks. It runs in your browser, gives you a lot of different metrics. If these graphs don't make any sense to you, no problem. We'll talk about them in a few minutes. But this one is really helpful. And as a bonus point, SPX, well, a fork of SPX is also bundled into Herd. So if you use Laravel Herd, you just need to install their extension, the SPX extension, and then you can use this locally right away. Good. So deterministic profilers, they are great. They give you a very precise output and they closely represent the actual flow through your application, but they add too much overhead. Again, we are recording every function that is called. And in the end, if you run something like this, like Xdebug on your production server, you will have a very bad time in terms of overhead. So everything will be slower. Your CPU, your memory usage will go up. You could, of course, sample this, right? Like, let's say you have a very high traffic application and you only want to profile every 1,000th, 10,000th, 100,000th request. But this won't give you like a really good representation about your overhead in your application. Because you will have like just a really small subset of things you can look at, and most importantly, outliers. So the things that you normally care the most about, you have to be really lucky to actually get them. So deterministic profilers we can't use in production because they have too much overhead. But what could we use in production then? So now we are basically going to the second kind of profilers that exist. And these are so-called sampling profilers. So instead of recording each function call, we set a certain interval, like 10 milliseconds. And every 10 milliseconds, we take a stack trace of your application state. This will give us less precise results, right? Because like everything that takes less than 10 milliseconds, you won't capture, but it will greatly reduce the overhead. And the idea behind this approach is that everything that is faster than 10 milliseconds, we might not care about as much, right? Because especially like in a web application, most of the time, the first problem or the first performance problem you run into is your database. And once you fix that, it takes a while until you actually get to the code you wrote. And then having stuff that is faster than milliseconds, you don't really care about. But of course, this is just a number, right? Like you can also sample at different intervals. Like if you need more resolution, you could go to 1 millisecond. So, but 10 milliseconds over the years was just, or like for web services, just a really good middle ground in terms of like overhead and still enough resolution to find your problems. Yeah, let's look at some sampling profilers that exist out there. There's one called Xzymer, and this is actually written, maintained, and used by Wikipedia. So Wikipedia still runs their stuff on PHP, and they were really keen to know where they spend time. So they built Xzymer. And we also use this at Sentry in terms of when you want to use PHP profiling in Sentry, you will need to install this extension. And the reason is it adds very little overhead. It's a very small code base. It's open source. And if it's good enough for Wikipedia, it's pretty much good enough for everyone else in the world. And just like in terms of scale, Wikipedia still uses Apache for all their things. and they're currently like at 1.6 billion requests per day. So roughly 20,000 requests per second. That's what they serve. And they serve all of this from 300 servers in their data centers. So a lot of people always say, oh, PHP doesn't scale, but if there's a will, no, like it definitely works also at much, much higher scale than what we are normally used to. Cool. So how does Excimer work? When extension spawns, we use a POSIX timer. So we basically ask the operating system, hey, after a certain amount of time has elapsed, please let us know. And then we can deliver this signal to a different thread, and then we can start to collect our stack sample. So in the case of Excimer, when we configure it with 10 milliseconds, it will spawn a background thread when the extension loads. And then every 10 milliseconds, it will basically tell us, hey, take a snapshot. In PHP, you sadly can't do this, right? But what we can do is every 10 milliseconds, we can set the VM interrupt global flag. And the cool thing about this flag is that every time there is a userland function, or with userland, I mean like a function written in PHP being called, before the function gets executed, this flag is being evaluated. So we call a function, we can check, hey, is this flag set? If it is, we take a snapshot of the stack trace. If not, we do not take anything. And the idea behind this is basically the chance that a new function is called every 10 milliseconds is pretty high. So every 10 milliseconds, we can actually take a snapshot. In PHP, that's just a problem when you call anything outside of the send engine. So for example, if you make a curl HTTP call, or if you make a database query using PDO, all of these things, they are not run inside the VM anymore. So we can't interrupt. So you can't collect any stack samples when you make a database query. If the database query takes 200 milliseconds, basically for these 200 milliseconds, nothing will be profiled. But the good thing about PHP is you don't really care about it, because for 200 milliseconds, your PHP application won't do anything else anyway. If we just talk about standard normal PHP, of course, if you use something like Franken PHP or any other asynchronous runtime, that looks a bit different. So yeah, it's not super precise, but again, it's precise enough. And evaluating this flag is also, like in terms of overhead, pretty low. And then when we took the snapshot, we just reset the flag back to 0. And then we move on with our life. Excimer is available on Packle, so you can just install it, but it's also available on a lot of Linux distribution, like on Ubuntu, you can install it via apt. Like all these package managers, they now carry Excimer. It's also available on Laravel Cloud by default. So if you happen to use this, it's already there. Yeah. If you want to use Excimer, because it's just a profiler, it has nothing to do with Sentry, so you can use it for whatever you want. You basically just create an instance, set a sample period in seconds. So in this example, that would be 1 millisecond. Then you can decide if you want a wall clock or CPU time, and then you just start it. And then on the shutdown function, you can just dump the output of the profiler into various file formats. And a pretty common one would be like speed scope. So speed scope is like a specific format that is understood by various tools. And this can then show you the output. That's how the speed scope website looks like. So you load the JSON in, and then you get the full overview of what happened in the application. So on the top, you have a small mini map where you can go left and right. Then you have your time axis. So as we said, like we sampled every 1 millisecond. So most of these samples in here are 1 millisecond long. And if they appear to be longer, well, then that means they just took way longer to run. So this already helps you to spot stuff that is pretty slow. When you go from the top, you normally have your entry points or your index PHP, or in this case, because this is running on Herd, so the entry point is the Valet survey PHP file. So this, of course, took the longest. But then from the top, you can like slowly trickle down to actually see the application, to see the stack frames you are most interested in. Sampling profilers are great because you can run them on production. They add very little overhead, but they're also not really precise because based on the sampling interval, we maybe miss a lot of functions being called. And as I mentioned before, every time we call out of PHP, curl, PDO, we don't get any data. So instead of just looking at one profile, maybe it would be great if we can take a lot of different profiles and combine them together. So this is basically what we call aggregation. If you have just one exemplar, sampling profile is very imprecise, but if you have many thousands, hundreds of thousands, and you can all aggregate them together, you can create like a much more insightful version of what the application is actually doing. So it gives you like a better average. The question is now, how do we aggregate such profiles or such aggregated profiles? And for that, there's something called flame graphs. So flame graphs, they were invented by a guy called Brandon Gregg. He's an engineer at Netflix. And a flame graph is meant to visualize hierarchical data. So you have visual stack traces of any profiler. And the whole idea is that the most frequent code paths to be the most frequent code paths in your application, you can identify them very quickly and also, more importantly, accurately. If you Google for flame graphs, there's a really nice 45-minute YouTube talk about why he saw the need to come up with profiles at Netflix, with flame graphs. So if you're curious, would definitely recommend that. So this is such an example of a flame graph. And when you see this for the first time, it looks weird, right? It's not a commonly used visualization. I mean, most of the time we are more used to bar charts, line charts, pie charts, but that looks weird. And it gets even weirder. So the problem is this is an aggregate, right? So in a flame graph, there is no information of time at all. So while you might say like, oh, this MySQL statement took 50 milliseconds in this visualization, well, we won't ever see it. What we see instead is on the x-axis, all the frames. So one block is called a frame. They're just sorted alphabetically from left to right. And on the y-axis, that's just our stack depth. So we start at 0 from the bottom, and then we go up. And the width of such a frame, this just represents to how often this function appeared in an exemplar of a profile we stored. So the wider it gets, the more often this function was called. This is an example of a flame graph from Wikipedia. And what you can spot here is there's a lot of guzzle, right? Like we have like 2 towers here. And yeah, now you could like maybe start to investigate, what is guzzle calling? Can I maybe improve this if it's even my stuff? So this is a good example where profiling can help. And Wikipedia, they ingest about 3 million samples a day. So they are not sampling every request. That would be way too much data at their scale. And they're also publishing them on their website. So if you're curious what the PHP code at Wikipedia is spending the most time on, you can just go there and take a look. I have some examples about why I think profiling is awesome, and more importantly, where it like helped me personally in my applications to fix them. So this is a screenshot from Sentry, because the application I'm building with, of course, they use Sentry inside. And as you can see, sometimes at the end of July or in the middle of July, actually, something happened, and one function in my app got a lot slower. So like from 50 milliseconds on average, it went to 250 milliseconds. And that's normally not a good sign. But that's like all the information you got, right? Like 50 milliseconds on 50 milliseconds. So how can we find out what's actually going on? And that's where we use profiling for. So this feature, this is called the most recursive functions feature. In our PHP SDK, we take the output of Xzymer, convert it to our own format, which is actually pretty similar to the speed scope JSON. And then we send it into our ingestion pipeline. And then from all of these profiles we collect, we store certain metrics for in-app frames, because then we can actually calculate these metrics, how long certain functions take. And we only do this for in-app functions, so basically everything that's not in the vendor folder. Okay, so I dove in a little bit. And this is now one exemplar. So this is not an aggregated flame graph anymore. This is just one profile. And as you can see, I was calling, or the framework I'm using basically, it called some initialize method, and this like took 300 milliseconds. In the flame chart, you see like blue and red frames. The blue frames is basically everything we consider in-app, and the red ones is everything that is like from a vendor library or framework. What's happening here is that user stable initialized, the first time it runs, it populates the schema cache, so that the framework can easily know how my database looks like, all the tables and so on. And every time this took 300 milliseconds, which is a bit weird. But the thing is, as we can see on the root frame, this is actually a CLI application. So this runs once an hour. It's a cron job. And every time when the cron job starts, the first 300 milliseconds, it's basically just spending time to do like schema reflection and to dump the schema into a cache file. Which on a normal server is not really a problem, because it writes the schema to disk and then you move on with your life. But I'm running this application in a Docker container. And even worse, I run it on Google Cloud Run. So Google Cloud Run is basically a service from Google where you can basically just run any Docker container you want to, expose it to the internet or not. And these containers are completely ephemeral, so they don't have any persistent storage. Well, at least not until you tell it to do so and pay for it. So every hour, the container got recreated from scratch, dumped the schema file, took 300 milliseconds. And now I know. Will I fix this? Of course not. Again, it runs once per hour. If it runs once per hour, I can spend 300 milliseconds. So for once in computer science, it wasn't DNS, it was actually caching. Yeah, and then another problem I noticed in my app was that I had a function and the P95, so the 95 percentile, basically the top 5% of invocations took 1.1 seconds. I know this function because I wrote it. It's not talking to any database. It's not making any HTTP calls, but 1.1 seconds is like crazy slow for a PHP function. So what is the PHP function doing? So my Slack app I run at Sentry, which is written in PHP, you can show people your appreciation by sending them potatoes, like potato emojis, 5 per day. And initially, the system resets the 5 per day counter every night at midnight. So it basically just did an SQL query looking how many potatoes you gave out until midnight. And if you already gave people 5, that's it. But Sentry being a global company, we have people in Vienna, Amsterdam, Toronto, San Francisco, Seattle. Midnight UTC wasn't really fitting. So what I did instead was like I calculate a local midnight based on the time zone in the Slack profile. And that was the code I came up with back then. So I basically just take all the time zones that are available in PHP, iterate over them, create a new date object, and then just check if in this time zone, the current hour is basically their midnight. If it is so, then I push it into array, and if not, I just ignore it. Cool. In theory, that's great. But when we actually look at the profiling data, it's not great because this function in this exemplar took like 900 milliseconds to run. Would I have ever found out the problem without profiling? With a lot of looking into it, yes. But then you just have to scan through your entire code base and basically think about, is this slow, is this fast? And with profiling, it was just like glaringly obvious. As you can see on the tooltip here, we even know the exact line in your application, so you can just go to GitHub or wherever you host your source code, look at it, then come to your own conclusions, or maybe you can just even feed it into an LLM and it will tell you what you're doing wrong. So yeah, it was tremendously helpful to find the root cause of the issue. And now I have to disappoint you. No, I haven't fixed this one either, because again, it's a cron job that runs once per hour and I just don't care. And it gives it gives for a nice demo of our profiling feature. Cool. That's all I had today. Thank you very much. And yeah, feel free to ask questions if you have any. Happy to dive in a little bit deeper.
Thank you, Michi. Thank you. If anyone has any questions, please feel free to ask. You can simply unmute yourself and ask your question.
Hey, Michi, and thanks, Abbas.
Hello.
So I want to know if Pulse or Cloud, or Pulse and Cloud both, are they also using certain? I think I know Pulse may be using, or Cloud is using 10% of the request for profiling, but is it something that is also considered while developing such products like Cloud or Pulse or anything custom?
Yeah. So what you are basically talking about is something called sampling, right? So on Pulse, or I guess probably Nightwatch would be better fitting. It's basically a trade-off you have to make, right? Like you can of course send 100% of your telemetry to a service, but this means you have to pay for it. They need to store it, and also they need to process it. So a good way to reduce like price or overhead is you just reduce the sampling rate. I think on Pulse, it's more important because this actually runs on your own hardware, right? Most of the time, maybe even on the same server. So you, of course, can't dedicate like a lot of resources to it, because else the application you actually care about won't have enough. Yeah, I mean, in general, it's I think it's a good, like at a certain scale, it's a really, really good idea to sample. I mean, I think our backend at Sentry sampled at less than 1%, because we have such a big volume that even with such a low sample rate, we still find most of the outliers. For exceptions, for example, we don't sample at all. Like we really want to have all errors coming in at 100%. because it's not so much about that every error is stored. It's more important that you have that the metrics are correct. So you kind of want how many times did the error happen? 500 times, 1,000 times, 500,000 times, right? Like this is really important to triage it, because if an error happened twice, you don't really care. And also the user count. So yeah, there's sadly no one size fits all answer to what is a good sampling rate. Anything above 50% is mostly not a good sample rate, that I can tell you. So you either do 100% or 50%, 25%. Yeah.
Thanks. And yes, I did actually mean to say Nightwatch instead of Cloud. So just a quick question. I won't take much time. Sorry, boss.
No issues.
When I think in Sentry, I read, I have not really implemented that bit of Sentry, wherein in the docs it does mention that if you have a certain version of Laravel and a certain extension installed, it can use the introduced feature in Laravel 11, wherein the Sentry will be sending updates after the request has been sent back to the browser. And that should, at least in theory, not put any additional load on the server sources itself.
Yeah. Okay. Cool. Yeah. I can definitely talk about this. Okay. So the problem with PHP is, again, default PHP, that everything is synchronous, right? You can't just do an async await somewhere or spawn a new thread. At least not in a web context. There is a threading extension, but that's more for the CLI. And at one point, all the telemetry that our SDK collected, so errors, logs, traces, profiles, we have to send it at some point. And for errors, we send them right away, because our thinking is an error is too important to be like postponed, because maybe you have an exception later on, you have an out of memory error, and then the exception is gone. You will never know about it. So we send it synchronously in the request. This takes a little bit of time, depends a little bit where you are. We do host our ingestion proxies around the world. So there's a bunch of in Asia, in Europe, also in the North and South America. But depending where your server is located, this just takes a little bit. But for all other telemetry, so like logs, traces, profiles, we don't really need to send them right away. We can basically wait until the request is done and send them then. And when you actually use Nginx, there is a really cool feature of Nginx where you can flush the response to the client, so like to the browser or whatever that connect to your website. And then it will still keep the PHP process alive, or this one request worker, and you can still do things. So in Laravel, this feature, they call it a terminal middleware. So in a middleware, you can have a terminate function, and this basically runs after the request was already flushed. And for example, if you use defer, it's the same thing. They all work with this principle, but they only work with Nginx. So if you use Apache, well, Apache also has FPM, sorry. So you need to use FPM. So the SAPI in PHP needs to be FPM. If you use the one from Nginx core, which is called, I forgot, then for example, this whole thing doesn't work. But yeah, we emit all our telemetry besides errors after the response went out. And we will also soon launch an agent you can run next to your application, which then even further reduces the round trip time, because instead of connecting directly to Sentry, the SDK will connect to the agent, which most preferable would run on the same server. So we are just looking like on a millisecond of overhead instead of like 150 milliseconds. Yeah.
Thanks. And would it be possible for, I'm not sure, would it be possible for that agent to be run on a proxy server or just an adjacent server?
Yeah, sure. I mean, like somewhere locally to your application would be great. It doesn't need to be the same server. It can also be a proxy. I mean, our ingestion proxy, it's called Relay. You can also host this locally. Then you basically have the Sentry ingest service right next door, but it's written in Rust. So it's a bit of a different tool chain, how it's run. the agent we are now offering it's completely written in PHP. So you don't need to worry about it. You can just install it via Composer and then just run it.
Thanks, Michi. Thanks, Abbas.
Welcome. Anyone else has any questions? Also, I have posted in the chat, I have posted a link to the PHP Storm license giveaway contest. Please fill in that form to enter the contest. I'll wait for 1 or 2 more minutes and then we will do the lucky draw. In the meantime, if anyone has anything to say, either questions for Michi or anything else to discuss or say around profiling, please feel free to unmute yourself and say. Okay, Michi, I think you had something more to show, right?
Yeah.
Let me hit the pause button on recording quickly.